Okay, so this is problems 18, 19, 20, and 21 from homework 1, week 1, and we are talking about the empirical rule and finding probabilities under the normal curve. So it says a study conducted on students from a particular high school over the last 8 years. The following information was found regarding standardized tests used for college entrance. Scores on the SAT are normally distributed, so they look like this, with a mean of 1,119 and a standard deviation of 203. The ACT has a mean of 22.2 with a standard deviation of 5.2. It is assumed that the two test measures the same aptitude but on different scales. All right, the SAT score, what SAT score is in the 20th percentile? So I am looking for where there is 20% of the area right here. This is 20%. They've given me a percent and are asking me for a cutoff. So the formula, the function that I need to use, either on my calculator or on Excel, is inverse normal. Right? They work a little bit different on the calculator or Excel, so you really need to pick one piece of technology that you are going to use to do this. So I will kind of type in the commands that you need for each of these different types of technology. And but again, this is why I put the TI-84 in the required list or at some sort of TI calculator, because it is so much easier to use the TI for the whole scope of this class than to have to be like pulling up Excel all the time. This handheld calculator is just going to make it a lot easier. But I will permit you to use Excel, and we'll go from there. So, okay, so using the TI, I'm going to go second vars, which takes me to the distribution button. Now I choose number 3. Which is the inverse normal. I apologize for that background noise. Number 3, which is inverse normal. And then hit enter. And it says, what area do you want? Well, I want the bottom 20%, so 0.20 and 0.2. And this is a mean, so it gives you a normal curve. It says like a standard normal curve, 0 and 1, but this isn't a standard normal curve. We have a mean of 1,119 and a standard deviation of 203. If I wasn't using this calculator, then I would need to convert this to a standard normal curve, first using a z-score, and then figure out the cutoff score from there. So it's very handy that I have this technology. And then it says left, right, center, so I can choose left. If your TI-83 is older and you don't have a newer TI, then you are going to just, it defaults to left. So you don't have to worry about that. And you hit paste and hit enter. And the answer here is my 20th percentile is 498, and it probably is round to the nearest whole, but if it wasn't, it's 0.15, right? If I were using Excel on this, so I'm going to go ahead and launch Excel. You won't be able to see it because of the, so everybody has Excel. even if you don't know it, it's through EOU, and it's the Microsoft 360, and you can download Excel from there. If I was to doing Excel on this, I would type equals in just put it in A1, equals inverse normal, so it's norm.inverse, parentheses, and then the probability, which is our left tail, so this is 0.2. And it also allows me to put in my mean, which is 1,119, and my standard deviation of 203, close parentheses, hit enter, and I get the same number out. So again, that was my left tail area, my mean, my standard deviation, close parentheses, hit enter, and I get the 948.1815, right? Right. Next one, find that the ACT, so now we're looking for the ACT score that's in the 20th percentile. We do the same exact steps we just took here, except for now we can just change these two change those two. So same exact steps, just change these numbers to 22.2 and 5.2. And that will give me an answer there. On my calculator, again, I would hit second. Again, there's no easier way than doing this than the TI-84. Second, VARS, inverse normal, which is number 3, area 0.2, mean 22.2, standard deviation 5.2, it's a left, and hit enter twice, and this number is going to be 17.8235. And I'm not sure, but I'm guessing that they just say 1 percentile, so this would be 0.2, 1 decimal place, and this would be 17.8. If a student gets a score of 1322, and what's their equivalent ACT score? So this is going to be kind of a two-step process, so I'm going to do it here for you on another page. So 22, and then again, I make sure we have all that copied down. All right, so here's our next problem. This is problem number 19. So we've got this curve. We looking at the prices of TVs. It tells us that we have a standard deviation of 120 and a median price of 1,200. Notice it's right in the middle of our curve. What's the probability that the buyer had paid between this amount and this amount, giving us two cutoffs, this amount and 1320. Now, this one we don't even need technology for, just because that's just one standard deviation away from the mean. So, if I add 120 here, so this is our 34%, right, from the empirical rule. But I could definitely use my technology. There's no reason why I shouldn't. And again, if I hit normal CDF on my calculator, so second VARS, normal CDF, and then put in my two cutoffs, my lower limit at 1,200, my upper limit at 1320, my mean at 1,200, and my standard deviation of 120. Hit enter, and it's going to give me, that 34%. Do the same thing here. Notice that's 2 standard deviations away. Less than this, that you're looking at that area below 2 standard deviations there. All of these are normal CDFs. So you can use that on Excel. If you don't have a calculator, and you want to use a function on Excel, then you hit the equal sign in the cell that you want, and then type in norm and norm.dist. Norm.dist. When you hit that one, it asks for your x value. Now this is the x to the left. So this is always going to be working left. So it's going to take you a little bit more work than the other one, because you're going to have to subtract the 2 when you're looking for 2 in between. So I would take the bigger one first, and then the mean and the standard deviation. And then it says, do you want a cumulative? And you're going to write true there, because you do want it cumulative. And then that's going to give you a number. It's actually going to give you 0.84 something, right? And then if you do the second one here, again, hit in norm dot, do the other cutoff, the lower cutoff. Now, obviously, this is going to be exactly 50% because it is the mean. And that's going to give you a number. This one, like I said, will be exactly 50%. You subtract the 2, and then you get the number that's in between. Okay, so this one, same idea. Here's our mean, here's our standard deviation. And again, we're just looking at these in between. So again, this function on your calculator is going to be normal CDF. They are giving us cutoffs, asking us for our probabilities. If they give us a percent and ask us for a cutoff, that's when we use inverse normal. And question number 21. Around the time to complete a physical activity class for PE is normally distributed with a mean of 37.6, a standard deviation of 5 seconds. What's the probability? The mean is less than. Again, this is a normal CDF. It's really nice if you draw the pictures and shade them in. What's the probability that there's more than this? And then in between, again, normal CDF for all of these, or norm.dist on Excel. And now this last one though, part D, that gives us a percent and asks us for a cutoff. So we're going to use inverse normal on this one. So you're going to put this here, you're going to look at 85% as your area, that's 0.85, and then you're going to look for this by typing in the mean and the standard deviation that you want. All right, hopefully that's helpful, and I wish you all the best of luck. Let me know if you have further questions. We all want to know, here's 13. And our mean is 1,119 with a standard deviation of 203. And the mean on the ACT was 22.2 with a standard deviation of 5.2. All right, so first I can do is figure out what percentile this is. So there's lots of different ways I could actually do this, but let's figure out what percentile this is. So let's find out how much area is underneath the curve here. So instead of using inverse normal, since they've given me a cutoff and I am looking for an area, I'm going to use normal CDF. All right. So again, second bars on my calculator. Normal CDF is number 2. All right, my lower limit is going to be negative infinity, so on my calculator I'm going to write this. Or I can just put a 1, negative 1, and a whole bunch of zeros after it. Right? And then my upper limit is this 1322. My mean is 1,119. My standard deviation is 203. I hit paste, and this is the 84th percentile. Okay. So now I have a percentile and here, and I want to know what number corresponds with the 84.13 percentile on this curve, on the 22.2. So this would be the same as the one I just did. So I would take my I can copy this big long number, 81.13447, just to get it as accurate as possible. So I take that number, and I do that second vars, inverse normal, which is number 3. That area that I can just type in mean of 22.2, standard deviation of 5.2, left tail, hit paste, and that would be equivalent to 27.4 on the ACT.